Electricity is a powerful force, one that has revolutionized the way we live and work. It can light our homes, power our devices, and keep us connected to the world. In critical moments, it can even restart a heart, bringing someone back from the brink of death. But it can also be dangerous, even deadly, if not handled with care and respect. When it comes to electrical safety, there are a lot of myths and misconceptions floating around, which can lead to serious accidents. Many people believe that high voltage is what kills, but this isn't entirely true. It's actually the current that poses the greatest risk. Others think that a quick jolt of electricity is harmless, which is also a dangerous misconception. Even a small shock can have serious consequences. The reality is more nuanced. Factors like the path the current takes through the body and the duration of exposure play crucial roles. This essay aims to debunk these myths and provide a clear understanding of what makes electricity dangerous, so you can make informed decisions. We'll explore the roles of both voltage and current and how they interact to create potentially hazardous situations. We'll also discuss the importance of source impedance, which can affect the severity of an electric shock, and delve into phenomena like dielectric breakdown, which can lead to unexpected and dangerous electrical discharges. By the end, you'll have a better understanding of how to stay safe around electricity, whether at home or at work. Remember, safety always comes first. Taking the time to understand these principles can make all the difference. Nirboto. The human body relies on electricity for many vital functions. Our nervous system uses tiny electrical impulses to transmit signals throughout the body. Our heart, the body's own electrical pump, keeps blood flowing with each rhythmic beat. These internal electrical signals are incredibly delicate. They operate on minuscule voltages far smaller than what we encounter in our homes and everyday life. This vulnerability is what makes electricity so dangerous to humans. Even small external voltages can overwhelm our body's internal electrical system. This disruption can cause muscles to seize, interfere with heart rhythms, and even lead to burns and tissue damage. Understanding our body's sensitivity to electricity is crucial for comprehending the very real dangers it poses. While voltage plays a significant role in electrical hazards, it's the current or amperage that ultimately determines the severity of an electric shock. Think of voltage as the pressure in a water pipe, while current is the actual flow of water through that pipe. A small trickle of water might be refreshing and harmless, but a raging torrent can be devastating and dangerous. Similarly, a small electrical current might cause just a tingling sensation, but a large current can be lethal. Take, for example, a car battery. It typically has a voltage of 12 volts, which seems relatively low and harmless. However, a car battery can deliver hundreds of amps of current, more than enough to be fatal if mishandled. It's the flow of current through the body that disrupts our internal electrical systems, causing injury or even death. This is why it's crucial to use proper safety equipment and follow guidelines when working with electricity. Understanding the difference between voltage and current can help prevent accidents and save lives. Another critical factor in electrical safety is source impedance. Impedance is the opposition to the flow of current. Think of it as the width of a water pipe. A wide pipe allows for a large flow of water, while a narrow pipe restricts the flow. Similarly, a low impedance source allows for a high current flow, while a high impedance source limits the current. This is why a static shock, while high in voltage, is generally harmless. Static electricity has high impedance, meaning it can't deliver a sustained current. On the other hand, a power outlet has low impedance and can deliver a large sustained current, making it much more dangerous. Section 5. Breaking barriers. When insulators fail. Insulators are materials that resist the flow of electricity. They are essential for safety, preventing electricity from flowing where it's not supposed to. However, even insulators have their limits. If the voltage across an insulator becomes too high, it can cause a phenomenon called dielectric breakdown. Imagine pushing a pin harder and harder against a piece of cardboard. Eventually the pin will break through. Similarly, high voltage can break through an insulator, causing it to conduct electricity. This can have dangerous consequences. For example, the insulation on a power cord can break down if it's damaged, creating a shock hazard. Section 6. Beyond the basics. The limits of Ohm's law. Ohm's law, V equals IR, is a fundamental principle in electricity. It forms the foundation for understanding how electrical circuits operate. It describes the relationship between voltage, V, current, I, and resistance, R. This relationship is crucial for designing and analyzing electrical systems. While useful, Ohm's law doesn't tell the whole story when it comes to electrical safety. It provides a simplified view that doesn't account for all real-world complexities. Other factors, like the frequency of the current and the duration of exposure, also play crucial roles. These factors can significantly alter the behavior of electrical currents and their effects on materials and human bodies. For example, high-frequency currents tend to flow over the surface of a conductor rather than through it. This phenomenon is known as the skin effect. This is why you can touch a Tesla coil, which operates at high frequencies without being harmed. The current doesn't penetrate deeply into the body, reducing the risk of injury. Similarly, the duration of exposure matters. A quick touch might not cause harm, but prolonged contact can be dangerous. A brief exposure to a high current might be survivable, while prolonged exposure to even a small current can be fatal. This highlights the importance of understanding the limits of Ohm's law and considering additional factors in electrical safety. Always use proper safety equipment and follow guidelines to protect yourself from electrical hazards. Remember, Ohm's law is just the beginning of understanding electricity. Comprehensive knowledge and respect for electrical principles are essential for working safely with electricity. Stay informed and stay safe. Section 7. Static shocks. More bark than bite. Static electricity is something we've all experienced. That annoying shock you get after walking across a carpet on a dry day is static electricity discharging. While startling, static shocks are generally harmless. This might seem counterintuitive, as static electricity can involve thousands of volts. However, the key lies in the duration and source impedance. Static discharges are incredibly brief, often lasting only microseconds. Additionally, the source impedance of static electricity is very high. This means that while the voltage might be high, the actual current delivered is minuscule. The total energy transferred, which determines the potential for harm, is very low. Section 8. Tesla coils. Spectacular but misunderstood. Tesla coils are captivating devices that produce spectacular high voltage discharges. They're often portrayed in movies as deadly weapons, but the reality is more nuanced. While Tesla coils can generate extremely high voltages, their design and operation make them surprisingly safe for humans. Firstly, Tesla coils operate at very high frequencies. As mentioned earlier, high-frequency currents tend to flow over the surface of a conductor rather than through it. Secondly, the discharges from a Tesla coil are extremely short in duration. This means that even though the voltage and current might be high, the total energy transferred is relatively low. So, Section 9. Respect the power. A final word on electrical safety. Electricity is a powerful force that can be both beneficial and dangerous. Understanding the factors that make electricity hazardous is crucial for staying safe. Remember, it's not just voltage that matters, but also current, source impedance, frequency, and duration of exposure. Never underestimate the power of electricity. Always treat electrical devices and wiring with caution. If you're unsure about something, consult a qualified electrician. By respecting the power of electricity and taking appropriate safety precautions, we can harness its benefits while avoiding its potential dangers.